Okay, here we go.
All right.
So did anybody have any questions with lesson 21? Or are we good to go and start on the quiz?
I think you're pretty good on 21. What do you think?
I'm good.
How about you, Emily?
I am not too positive about how they found the correlation coefficient.
Okay.
For that one, like I looked at what he did, and I think I might have had the wrong data, and that's why it wasn't working.
For 21 in the preparation?
Uh-huh. I think I had the wrong data, and that's why.
What numbers?
For number 1 and then 2.
The Gharial crocodiles data.
Yeah, the part 2.
With 2 data.
And I think what it was is that I just did the wrong data. I think I did the other crocodile one.
Instead of Gharial crocodile, you did.
I did the other one.
Oh, okay. That would probably make sense. But did you understand how to find it?
Yeah, so the Pearson correlation, it's the 0.986. I just figured it out right now. So I think that's what it was, is that it wasn't matching because I had a different data set. So I'm good there.
Okay. That's good to know. Try another way. Is there any other questions, Raquel, for you? Raquel with us?
Basically, it's R times SX times SY. That
We
was,
lost Raquel.
but the covariance.
Okay, hold on. We lost Raquel.
Uh-oh.
More questions I had was on lesson 22, the part 2. I didn't really, I need to look over it more, but how to find it in the SPSS.
Yeah, I kind of know how to figure it out on the SPSS and everything. I just didn't understand it.
Yeah. Maybe we can go over that part so we can just get started on the quiz, and then we can leave more time for lesson 22 and then whatever for our group project. Okay. Well, while we're waiting for Raquel, I don't know, what do you guys want to get started on the quiz? I haven't heard back from her.
Yeah, we can.
Okay.
All right, I'm deciding I'll do my quiz on this computer. Okay. That means I gotta go here. X out of there. There. Sign in. Again. Oops. Oh, great.
Okay, I just opened up the first SPSS document. When you guys are ready.
Uh-oh.
I'm ready.
Okay. So,
Now we're on week 12.
no, we're almost done. So excited. Okay,
Not me.
all
Not
right.
me. Because I don't like them. I don't know why. I just don't. I'm happy to have the class all semester long and no exam.
It's been a good class. So, okay. So number 3, the correlation coefficient is used to quantify, and I'm pretty sure it's the strength and direction of a linear relationship.
I agree.
Yeah. The strength and which one? The third one?
Yep. Or direction and strength of a linear relationship. Bless you.
The strength and reliability of the linear, the direction and strength. Yeah, that's the one.
Okay, so if the correlation, number 4, if the correlation coefficient is negative, when one variable increases,
Okay. If the correlation coefficient is negative when one variable increases, the other variable is negative. Is that right?
It'll decrease, right?
Decrease, yeah.
Is that right? Or is it negative?
that's in looking at my notes. So one increases.
I think if it was talking about positive,
If it's negative and if it's when one variable increases, the other variable would decrease.
Yeah, I think that's what it is.
yeah, it says when an increase in one variable is associated with a decrease in the other variable, we say that there is a negative association between
Down.
two variables.
Yeah.
Okay. Raquel, so we're on the quiz right now. Are you there?
Did she come on?
She's on, but I don't know. We can just keep going because if anything, she can always come back. We can catch her up just so that we're not losing time. So, true or false? The effect of the outlier on the correlation coefficient is not significant.
That's false. That is very significant.
Yes. Okay, so now everybody open up the Old Faithful document.
Oh, let me see if it's already open on mine. Mine's already open. I didn't close it when I did it last night.
So the Old Faithful. So it's asking us to input the correlation coefficient.
Okay.
Analyze.
My data. Analyze. What was it again? We analyzed descriptive. I forgot.
Analyze correlation bivariate.
That's right. I forgot.
And then you have to go do analyze.
Yeah, already in place.
Descriptive and then descriptives.
Okay. So we take 3.4788.
I got 0.901.
3.488.
Wait, are we doing the covariation? Oh, correlation. Isn't the correlation coefficient where it's just a 0.901?
Oh, right over there. Okay. We would do the covariance. 0.901?
Yep.
What is the direction and strength between the weight and duration?
I would say positive and strong because it's close to 1 and it's
Okay.
a positive number.
Okay, just a second. You're right.
Okay. So A matches scatter plot with the correct coefficient. So I guess we can make a scatter plot real fast.
Matched it. I would say it would be number 2. It's not absolute. It wasn't a 1.
You don't pinch.
Yeah.
Okay. I'm just making
Okay. Oh, I see. This is a whole different question. Match the scatter plot with the correlation coefficient. Oh,
Oh! I see what
okay.
it's at. I didn't look down. I was thinking it was for the
Okay,
other one.
1. Okay, 1 would be number 4 because it's
Wait, wait, wait.
absolute and it's going down. Negative, minus
Oh,
1.
it's like negative. Okay.
Oh, I'm
And then
sorry. That is R equal minus 1. R equal minus 6.
R equals negative 0.6. You mean? Oh. That's I don't understand. Hold on. I need to plug my computer in real fast.
Okay, I can kind of hear you guys now, but what number are we on?
Row number 8.
Minus 6.
Yes.
Okay.
Okay. I think R minus 6. What do you think it is this number 6? R equal minus 0.6?
I don't understand how you can tell that.
Because it's going down.
Yeah. But how do you know it's the 0.6?
I just sort of wrote it down in my notes. So,
You go to our text, but it has a list of different figures that show similar graphs.
Okay.
and R equal 1 would be the one that's positive straight up to the
Would be number 1, right?
Number
Yeah.
1.
number 1.
What was the R equals 0.95? Would that be
That would be okay, if it's negative, it's approximately downward.
I would say number 2.
Yeah, that's what I'm thinking. 0.95 would be 2. And then
Uh,
R equals
I thought that would be number 5.
Yeah, because it's negative.
2 is that's positive. That's right. She's right.
number 5 is the negative 9.5. And then 0 would be C.
Is
Or
the one
3.
scattered all over the place. Yeah, number 3.
Negative 0.06. Is that number 6?
Yeah.
Number 5 is number 2.
So we can just talk. So in order, it'd be 4, 6, 2, 1, 3, 5. So
The
what everybody
first one
has.
is 4.
Yep.
The first one is 6. R equal minus 0.6. The very first one is R equal minus 0.6 is 6. The next one is R is equal minus 1 is 4. That's absolute going downward.
Okay.
I
So do we everybody have
have
those?
3, 2, 4. Hey, I answered 4 twice.
I have 6, 4, 1, 3, 2.
I think all of ours are different, to be honest. The order. So I'll just read it in order. R equals negative 1 is number 4. R equals negative 0.6 is 6. R equals 0.95 is 2. R equals 1 is 1. R equals 0 is 3. And R equals negative 0.95 is 5.
That's what I got.
Okay. That's
Now the next folder is the math self-efficacy data. Let's open that up. Agent, so no.
That's false.
Okay.
Okay, so we need to input the correlation coefficient. So we want to do the SPSS stuff again.
Okay, so I have mine is 641352. Is that right?
Um, hold on. I got 0.728.
Okay. Oh,
We're just doing the correlation, so it's just that one number.
okay. Math. Okay.
I'm doing the score and the confidence rating as your variables.
Analyze, correlate, bivariate.
Yep.
Okay. Score. And confidence. Okay. Is it 0.728?
Yep, that's what I got.
I'm so slow.
You are good.
Okay.
So then what is the direction and strength between the score and confidence? I would say it is positive and strong. What do you guys say?
Yeah, it's positive and strong
I think the same.
because it is 0.728.
Hey, we got 100%.
So come again with those numbers on the 641352. What are the numbers on the scatter plot?
So for now, we all have different, the order of our numbers is different. So
Really?
yeah, it's all different. But if you match up to what I had before, we all got 100%.
Like minus 0.6 is 6. R is equal minus 1 is 4. R equal 1 is 1. R equal 0 is 3. And R equal minus 0.95 is
5.
5. And R equal 0.95 is 2.
Yep, you got all of them right.
Okay. So I didn't save 8. Okay. Yay! Yay for Marissa.
I didn't do that right. You all did it.
Go to submit.
Hey, you guys are smart. We have a smart group. You know, lesson 22.
Yeah, we're all right on your coattail.
Oh my gosh, not even. I think you guys are doing way better than I am here.
Okay, lesson 22.
Okay.
Okay.
So I have questions. If we could even go over part 2 together, it didn't really make sense to me. I kind of understand it, but not really. I feel like my mind is just kind of mush right now, so.
Join the club.
I was starting to go over and watch his preparation, like how the guy that goes over and does the lesson, or the prep lesson. But I didn't finish it all before we met.
Oh, this is the one where you do the
Right.
y hat equal 2 plus 1.5 times the x.
Yeah.
So basically, however many x we have, that's what we multiply it with. What is the y-intercept?
Are we on number 3?
So
So,
number 3. It wants us to math.
Is it part 1 or part 2?
I think she's on part 1.
Okay.
Yeah.
If you look at the line that they give, do you guys see how they identify the slope.
Yeah.
Okay, math.
There's negative 2.2.
Yeah, I got that, and then the y-intercept is 1.34.
Yeah. And then you guys put, for the x part, you put 5. Did you guys do that for the number 5?
Yeah.
They gave you the x value? Okay.
And then you minus that, because isn't it usually you plus it, but because it's negative 2.2, you just minus it.
Are we doing a regression on this one?
Now, where are you at?
I am on the math .sav, whatever it was, on the question 3.
So on the preparation, 22 preparation.
Oh no, I'm on the quiz. I'm sorry. I was on the quiz.
Oh, you're good. We are on lesson 22.
Yeah. I thought we were going to be brave. Sorry.
Oh, don't be sorry. No, I don't understand it enough to go jump on the quiz. I was thinking we can go over part 2,
Okay.
Yeah.
and then we can go just to make sure everybody's clear on it. Bless you. Bless you.
Well, I had to go back and look at. I understand the formula better than I did SPSS. I had to literally go back and look at the steps in SPSS every time.
Regression equation.
So I got 1 through 5 on the first part. It's the second part.
The part 2.
Yeah,
That one I got pretty good to be able to identify what he was going over, because I watched his video all the way through.
I watched the teacher's video. I didn't
I didn't see the teacher's video. I was doing the guy's video.
Oh, the student.
It's kind of like what is causing it. That's the independent variable. It's kind of like when we were doing the crocodile. We always had the head as the independent, is the x, because that's what determined how long the body is. So it's kind of like the boat, and the reduction of the manatee. So the boat was the independent of the x. So whatever the boat did, it affect the manatee, the reduction of the manatee. And so the boat is the x and the manatee is the y. So one is the independent and the other one is the dependent, because the manatee can't be the x because it doesn't do anything to the boat, but the boat does something to the manatee.
Mm-hmm. So for one, its head length is the explanatory variable.
And that's x.
Yeah, that is the x. And the body length should be the y. And so depending on what it is. So anyway, so the formula on that one is the, was it the y-intercept plus the slope multiplied by the x?
So, do you guys know how to bring it up on your SPSS?
Yeah, so on 3, you just create a scatter plot, so you just go graphs, legacy dialogues, and then scatter plot, right?
Okay, yeah.
But so my question, so just to make sure, so the explanatory variable is x, so that would be
Head.
The head.
head length is the x-axis, right?
Yeah.
Yes.
The head length is the x and the
body length is y.
Yeah.
Okay, so I just want to make sure. I like to redo it just to make sure I'm actually doing it.
Whatever is causing the other is making a difference, or making, causing something to happen on the other variable. The other one is the dependent, the other one is the independent.
Yeah. Okay, so then this is where how to use the software to compute the value of y-intercept in the regression line. So how do we do that in SPSS?
You go to analyze.
Okay.
And then go to regression and go to linear.
Yeah, linear.
Is it okay? Just linear.
And then you do dependent for body length, and then independent is the head.
Yeah.
And then you click on save, and you check the box unstandarized at the top.
Okay, wait, hold on just a second. So dependent is head length, you said?
No, body is dependent.
Okay. That's where I'm just going back over because I had this pulled up from before and I had it wrong. So body length is dependent. And then, sorry, where do you go next?
You do save.
How do you save?
It's on the right side. There's a box or box,
Save right there.
and then you check the
Hit
box unstandarized.
Unstandardized. And then do you press save again?
You press OK or continue, whatever.
Mine doesn't. So that's the thing is, mine doesn't. I can't press OK, and that's where I got stuck. So do I have to put anything in block 1 of 1, or?
Oh, you have to, for the independent, under block 1 of 1, you put the head for the independent.
Oh, okay, that's I went wrong.
And then push OK.
Okay. Okay, guys, you were awesome. Sorry, I was like, I don't know why, but I was stuck on that one.
No worries. And then you go to the coefficients table, and that's where you find your y-intercept and then your slope.
Okay, so I remember looking on, I don't know, where's the y-intercept again? What?
It's under the B column, so the,
Negative 69.369, right?
yeah. So that's your y-intercept, which is BO in the equation.
Okay, man, this would make more sense because I did not have my stuff right. So.
No worries. And then 7.4 is your slope, and that's the B1.
Okay, let me ask you this, Emily. On the math, what was the X? Is the confidence the X, or is the score the X? I put down confidence as the X and the score as the dependent. So, however confident you are, the higher your score. Sorry,
No, you're fine. That's even more than I know.
Confidence, I think it.
That's what I thought. That's what I put down. Confidence, I put it down as the X, and the score was the Y.
Right.
It affects the score. The more confident, the better you score.
That makes sense.
Except in my case, I'd probably be an outlier.
Okay.
Sorry, I'm writing this down in my notes.
You're fine.
Okay, so then the regression line. How do you do the regression line?
If you gotta double click your table box, so you could just scatter
Do the coefficients?
your graph.
Wait, because it says to draw a regression line and scatter plot. So create a scatter plot in SPSS. Oh,
Yeah, you do that.
Graph.
And you have to double click it to open it. And it'll bring up a table that says chart editor.
Have you gotten you a scatter plot?
You guys have your scatter plots done?
yeah, I have my scatter plot done. So I'm clicking it. So double click to activate.
Yeah, you double click on it.
Then elements, fit line.
Yeah. Fit line at total.
And then do we have to change anything? It doesn't say it in our work or.
I don't think so. I think it's just you do that and then it does the line for you. And then you just exit out.
So I guess why I ask is because mine I can't press apply or OK. So I feel like I don't know how to.
You did fit line at total, is that right?
Okay, I just had to click off it and choose something else. Okay, it's just thinking now. Or never mind.
Did you hit element and then fit together the line?
Yeah, fit line at total, but then mine, it'll only, if I have to click off on another thing.
I just push an X after, and then it just applies it to the graph on the SPSS output.
Oh, maybe I have done it. Oh, I always forget which this one is.
I think it should just automatically do it.
And it's just like a blue line around it, right?
It's just like a blue line that crosses
Yeah.
amongst the data points.
Here, I'm gonna screen share mine just to make sure I did it right. Yeah, guys, I'm slow today. Okay, is that it?
Yeah, I think so. Mine's a little different from yours, but I think it's the same idea. It's just that it does that straight line across.
Yeah, that's the one.
Okay.
Yours is a little strange. It's got blue on it. How come yours is fancy and ours is just plain?
No, I don't know. Oh, it might be just where I was clicking. Because when I clicked off of it, I don't know.
Okay. You guys ready for 8?
Yep.
You go to your data points, so that data that lists all the different numbers, and you go to the one that says 51, because it says for the observed head length of 51, so you go to head length and find the number 51. And you find
That was probably the easiest one, and it took me forever to figure that out.
That's it.
Body length?
And then you do the observed body length that's right next to it, which is 343. You put centimeters at the end.
Where did you, can you screen share, do you have your SPS? You don't have to have it open if you don't have it. Mine, I don't have 51 in here, so that's why.
Well, you go to the bottom of your data and you put 51 on the X because that will determine the length of your.
What are you talking about? Put 50, oh, here, Emily, let me. Oh, you have to go into the actual SPSS.
Yes.
Okay, so you
Is that what you did, Emily? Did you go to the bottom and just put in the 51 and then?
No, I just found the 51 right here, and it had the corresponding number.
So it's just 343?
Yeah.
Oh my gosh, I'm overthinking this. Okay, so use the regression line you obtained in number 2 to predict the body length based on a head length of 51.
And then the next one is I have it highlighted. It's the pre-table that, or the pre-column that we created.
Hold on, how did you get that? Or have we already done that?
I think it automatically did it when we were doing our regression line stuff.
Oh, it's right here.
Yeah.
Okay, so it's 308.03297.
Yeah, and then they have it, it's a little different on our answer sheet though, but it's probably because they did it probably by hand or something.
Isn't that the one where they did one by hand and one in SPSS?
Yeah, I think I didn't look at the upper ones because I just wanted to know how to do it in SPSS. But you can probably do it by hand. I thought I read somewhere where it's difficult because of rounding and stuff.
Yeah. I think it didn't say that we'd get 2 different answers, like whether it was like hand calculating versus
Yeah.
PSS. Like you'll get like it'll be just a little bit different.
Yeah, it says even though we can do this with the calculator, it's a little tedious and is subject to rounding errors.
Yeah.
Yeah, so that's what.
Where to do it by hand? Wouldn't we be just timesing 51 by 343?
Yeah, I think by hand it's y hat equals negative 69.369 plus 7. And then 51 is the x value.
Oh, which is 7.4. Right?
Well, the x would be 51, I think.
Oh, okay. Yeah.
Does that make sense?
Yeah.
Yeah, X51, that's the head length.
Okay, I'm just like trying in my calculator. Yeah, I got 2. I think I got a different answer. I got negative 26179.860, which is definitely not 308.
If you look at my calculator, I have it on there.
Oh, that's what you put in parentheses. This is 69.
Yeah, because it's negative.
Oh, 369. Oh, I times it. I didn't plus it. Okay, that's where I went wrong.
You plus it and then times the x.
Okay, I got it. Okay, sorry. I times the two numbers. Okay.
You plus the two numbers and then
That's good. And so then it says, why are the values obtained in 8 and 9 different? Is it? I don't know why. Is it just because the points are not exactly in the best line of fit? That's what the NDQ says.
Maybe because it's an estimate.
I'm looking at the answer key. It says the values are different because the points are not all exactly on the line of best fit. If you look at the graph visually, you can see that the actual point of 51 centimeters is notably above the line. The line equation is the best estimate, but it's not the actual observed measurements. That makes sense. Okay, that makes more sense, guys. I think I understand this lesson now. It was just the whole variables. I kept putting them in the wrong one, so I was getting everything else wrong.
No, you're totally fine. I think it's hard to differentiate.
Yeah. Okay, well, we're ready for the group quiz?
I am.
Okay, I will get on.
Oh.
Bubbles, yeah, those.
Oh, Papa.
Okay, so
Yeah. Oh. Oh.
okay, so is everybody on number 3?
Yes.
So the y-intercept. Hold on.
2.0.
ask you on the math.
No. Yep. And then linear, given the linear equation, what is the slope? It's 1.5, right?
Okay, analyze. Linear.
So then, so what's the? So it's asking what the predicted value is. Round to 1 decimal.
I got 1.
When X is 6.
Okay, just a second.
I got 1. Okay. So now for number 6, we need to open up the math self-efficacy.
I think it's hot dog shaped.
So where are you guys at? I'm like,
Number 7.
Are we on number 6?
I think we're on number. Oh yeah, 6. Sorry.
Okay.
I was thinking for the next 7 questions. It'll. Yes, get out. I know.
So we do a scatter plot.
Sorry, mine is still loading.
which one do you got? Which one did
I
you
got hot dog.
Hot dog?
Which one do we put for the y-axis?
That's the.
Okay, hot dog. What does it say?
So Y is the score.
And then X is
Is it confidence rating?
confidence.
This is X.
So what is it called?
Okay, so confidence is for the explanatory variable, which is the y, and the score is the response variable, which is the x. Yep, sorry. Okay, so mine looks like a hot dog shape.
Then it's not linear, is it?
Mine's kind of scattered. Is yours scattered?
I'll show you what mine looks like.
linear or not? No, it is linear.
Okay, I'll just change mine. Is that what everybody else's looks like?
Oh, yeah. Okay. I was a little worried. I was like,
No, mine looks the same.
hot dog?
So 7, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? Well, it looks like it's still positive. I'd say moderate. I don't really know.
I would say simple regression is appropriate because the y-intercept is not negative.
Yeah.
And in the video, he said if it's negative, it's not appropriate.
Okay.
That's the only reason. I don't know if that's right, but that's my guess.
Yeah.
Oh, okay. Got it.
And how many observations are in the data?
I think there's 139. I just scrolled down on the SPS and looked at the last entry. I think I'm not sure that's what that meant.
I think I got 139 too, but I don't know. I'm pretty sure that's how many observations there are. So I guess we need to go in and do, because it's asking what's the y-intercept, so we need to go, this is where we go regression, linear, right?
Are you guys in the quiz?
18.69.
Yeah, we're in the quiz.
Okay, what number are you?
We're on number 9.
Oh my gosh, I was waiting. I thought you guys haven't started.
Oh no, we've been going through. Where are you at?
I'm on the third one on the math thing, where 2.0 plus 1.5.
Wait, what do you mean, what math thing? Oh, okay, so question 3. So yeah, we have 2.0 as the linear regression, or the y-intercept.
5 times, what was the x? 139?
What are...
Times the x.
No, where are you at, though?
I am on group quiz
3?
lesson 2, yeah, on number 3.
Okay, so it's 3, it's just asking what the y-intercept is, so it's just 2.0.
Give the linear regression. Oh, I thought it was wanting us to figure it out.
Oh, no, that's in question number 5.
Okay, and number 4, give the linear equation y equal 2.0 plus 1.5. What is the slope? It's 1.5, obviously. Given the linear regression y equal minus 3.25, what is the value of the y when x is equal 16? Okay, now I've got time plus 3 point plus 0.25 times, if x is equal 16, 6.25.
I got, what number are you on?
Number 5.
I think we just got 1.
times 16 equals 52. Is it?
I got one.
It's 3 plus 0.25 equal 3.25, and then you times that by 16 because x is equal 16.
Yeah.
Okay. It's negative 3.
I got one.
0.2
I got one.
I got one too.
times 16. Five.
Sorry, I'm changing a diaper.
What did you get on number 5?
1.
How did you get 1? Because mine is 3.
2.0 plus 1.5 and then in parentheses, or just times 1.5 times 16.
I got, if you plus minus 3 plus 0.25, you get minus 2.75, and then you times that by 16, you get negative 44.
Hold on, just a
That's
second.
not what. That's not what I got.
Okay,
I will put in my calculator.
negative 3 plus 0.25 equals minus 2.75 times 16, which x was 16,
If you
negative 44.
if you look at my phone, Fino,
I'm on question 5. Given the linear regression equation is y equal minus 3.0 plus 0.25 times x, what is the predicted value of y when x is equal 16?
look at my phone on the screen, Fino.
Okay, hang on a second. Okay. Okay, I barely see it. Sorry.
So you do negative 3.0 plus 0.25 and multiply by 16.
Okay, let me do it again. Negative 3 plus 0.25 times 16. Wow. Oh, you have to put them all together.
Mm-hmm.
Okay.
You'll get 1.
I had it because I did it separately. I got a different answer.
Oh.
That's
Okay. And number 6. Which shape best describe the data?
Hot
good.
dog.
Hot dog.
Hot dog.
Okay. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model this data? Okay. Simple.
We said the first one, which is simple linear regression is appropriate for these data.
Okay. Because it was simple linear, was it? How many, okay, number 8, how many observations are in the data? So do we literally go look at the data?
Yeah.
Okay.
We got 139.
Yep, 139. Sorry, you guys.
Oh, it's okay.
You're
Okay,
good.
So
okay,
now,
what's the y-intercept?
the y-intercept, I went and put it in. Isn't that 18.690?
Yeah,
Yes.
Uh,
that's
Oh.
found now by doing the analyze
yeah,
and doing the regression linear.
yeah, I got it. It's 18.690.
Okay.
And 10 is 12.695, right?
Low.
Yeah. That's what I got.
So
And
the
we're on number 11, right?
12.695. What was the slope? 12.695.
The slope, yes.
And now 11. What is the predicted value of y when x is equal 4?
Sorry.
So now we're going to go,
Did you
okay,
guys get, I got 69.47.
18.690 plus 12.695.
Oh, poor little guy.
Sorry, he's choking on his apple juice.
He
Is
sounds.
he okay?
Yeah, he's okay. He's just.
69.47.
Yep, that's what I got.
That's what I got too.
What'd you guys get?
69.47.
What did you guys enter in your calculator?
18.690 plus 12.695 times 4.
Yeah. Take the y-intercept plus the slope multiplied by 4.
Is it 6.9 or 69?
69.47.
Yeah.
Okay. Thank you.
You're welcome.
The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these data for these values of x? Round to 3 decimals. Because there is positive correlation, we can use the largest x value to find the largest predicted value of y.
Oh, man.
I don't get that one.
This was in that. He went over it in the video.
Oh, great.
So the X value is score, right? Or is that confidence?
Yes.
Yeah, the X value is 4.
Oh, so if we
highest
make
value?
it 6,
If we make it 6,
and multiply it out, is that going to be the answer? Is that how we're supposed to do it?
18.690, whoopsie daisy. I can't even.
94.86.
12.695. 69.47 times 6. 421.515.
I got 94.86.
Oh, what did I do wrong?
I don't know. Maybe let's see who else has something.
Okay. Are we taking 12.695 and add 69.7 and times 6?
I'm not really sure. To be honest, I'm gonna open the
Yes,
section.
the 18.69. Basically, we just changed the x from
Yeah,
4 to
That's
6.
the only thing we're changing. 18.690
5.
plus 12.695 times 6. 94.86.
Yeah.
That's what I got.
Another way you can check it, which is the way I did with the way the homework or the preparation did it, is if you go on the screen and you go to your data like we did last time and you find the highest point, which is 6
Okay.
on confidence rating.
Okay.
If you top and you see the pre-1, it's 94.859.
Ah,
And so you can check to confirm it. But it's the same if you find any confidence rating at 6, it comes up with the same answer.
Oh, you put 6 on the X?
No, I didn't input 6. I just found 6.
Where?
are you looking at the scatter plot?
Oh, is that the scatter plot? 6
Oh.
away.
If you look at that, you can estimate it
Data.
too.
Was that in the data?
Yeah. You find 6. It matches with the computation you did. There's multiple 6 in this column, but they come out with the same answer on this side.
Ah, this one says 94.85.
And then you can probably round, or if it doesn't need.
Oh.
But it says 3 decimal places, so we might want to do the 5-9.
94.859.
Well, it says 3 decimal places, so that's my guess, unless you guys feel different.
Okay.
Right. So 859.
I don't know if that's right, but that's my best guess.
All right. Hold the bus, Gus. Okay. Oh, I see why it came out as a 94.86. We just the calculator just automatically just rounded it up to 94.86.
Right.
So either, yeah, it's good. It's
we
all.
did our linear calculation, which brings up that extra column on our data set as pre_1.
Wait, how do you do that extra calculation on SPSS or that model?
You just do your regular, when you guys do it to get your x and your y, or your slope and your y-intercept.
Is it with the scatter plot?
Or is it the linear regression?
Oh, Emily was just talking about looking at the data, Marissa.
I know, but I just don't have the extra column, so I'm trying to figure out. I forgot how to get there. Get that.
Yeah, you do, when you
Is
go
it say? Go ahead.
when you do the linear regression thing and you get your points for the y-intercept and your slope, where you get the 18.690 and the 12.695, and you go back to your data set, it shows the pre-1.
See, mine just doesn't come up with another variable, so that's why I was.
Do you have a thing that has the heading residual statistics? Because it's in there too, under minimum and maximum predicted value.
Residual and regression.
Oh yeah, I can see it. So where are you saying the number is? The
Uh-huh.
94. Oh, because that's the maximum. So that's a good way to see it. Right here where my mouse is on the table.
Okay.
So we're kind of saying that the maximum, which would be 6, is right there where my mouse is, under the residuals statistics at the top row on the bottom table. Do you see that?
The bottom table.
I see it on yours, but I don't have that on mine.
Did you do
So
your
what is
linear?
bottom minus 3.391, or
Did you do the regression, Marisa?
I did the regression.
Regression linear. Yeah, I have it. So I put dependent as my score. Save. Oh, I need to click unstandardized.
Oh, there, you're right. It's right there. It's 94.85. 859. So
Yep. That's another way we
round
can.
it up to 94.86. That is correct.
That's a good tip, Raquel. Good job.
Thanks. I just happened to notice it.
Okay, there we go. I just didn't.
Purely by accident.
Go, Raquel.
Beautiful
Well, we did
accidental
it.
miracles.
So it was one number plus the other number times 6. Yeah.
Okay.
So are we all ready for 13?
Yep.
Yeah.
How many explanatory or independent variables are present in simple linear regression? I think there's one, right?
It's 1. If it's
It wouldn't
saying
be simple if it wasn't one.
Yeah. I like that. So then 14, how many response or dependent variables are present in simple linear regression?
1.
Just one.
If it's more than 1, that's a little more complicated.
Yes, we're not ready for that. I'm not, at least. Okay, so 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, the lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable? So the response variable is what we're trying to predict, which...
Okay, what is the X?
hat.
Oh,
The hats. Because it's the variable being predicted.
yes, it
The
is.
size of the hat.
So the size of the hat, because the first one you said?
Yeah, my appointment's tomorrow. At what?
Okay, I'm gonna submit it.
Yes, I got that. Okay, thanks. Bye.
100%.
Okay, what was the last question of this stupid phone call? Got me distracted. Okay, what was the X?
The size of the hat because it is the variable being predicted.
So we're looking for the Y variable because it's the dependent variable, the response variable.
Right.
So we're wanting to know what the size of the hat is. So that's what we're trying to predict.
So which one was it? The circumference because it is being predict.
I gotta go to the bathroom. I'll be right back.
Is it the last one, Marissa? The
It's the
circumference
first one.
because it's being.
We're trying to figure out the size of the hat. So it's the first one. That's the response variable. So that's what we're trying to predict.
So you agree it's the first one?
I think, yeah, it's the first one. I just got 100.
It's the first one. Hooray for Marissa and Raquel.
And
Marissa and Raquel.
I wasn't the hero in this. You guys all were.
All right. Yeah, I was in La La Land.
My brain is shut down this weekend. Okay. Emily's going to the bathroom right now, but
Yay!
Hooray! Now we can breathe. We should have, group exam. Oh, man.
kill it.
That stuff is.
Yeah, we'd all be getting good grades.
Yes, we'd all have perfect score.
My test scores, though, they're very consistent. They're within 3 points of each other.
I was looking at mine. I progressively have just gone up. My first test, I've improved by 10 percentage points.
Wow, that's cool.
Wow, that's awesome.
Yeah.
I've been happy to see that I keep getting better. I've been improving. I've never done this well in a math class. I'll let you know that. I owe it to you guys.
So I didn't make any progress. I stay the same.
But you're consistently very good. I was not consistently good.
Yeah, me either. I actually made the highest score on the first exam, which is crazy.
Woohoo!
That's awesome. Go, Raquel.
Oh, I went ahead and I added the graph in the PowerPoint, and then the one that's due this week. The only thing we have left to do is write the paragraph part of it about explaining our results, our statistics.
Okay, I went into it, Raquel, and I wrote it about 4 o'clock this morning, so if it looks coherent, you can edit it. I basically wrote the whole thing. You can go through it and decide what you want to change and what you want, So anyway.
Yay.
It's all in red. Do you see it's all in red? The one that you send us?
Oh, I'm trying to open it right now, but my internet, when it's on video, it struggles. It's still waiting to open. But I'll look at it, and I guess when we all look at it, then we can vote, and one of us can turn it in. Next week
What are we-
I'm going to be out of town, so I'm trying to make my
You're going
week
to
as light as possible next week.
go see Marissa.
What about me? Sorry, I'm zoning out.
Text is Marissa. Is that right, Raquel?
So are we in the describe the data? Is that where you guys are?
Yes.
I've already finished mine and I could submit, but I think one person's supposed to submit for the whole group.
Yeah.
But I went in and I did the describe the data on it. So,
Wait, did you share that file with us? Sorry, my
okay, let me.
computer has been really slow.
Okay, where is it? That's the problem. I don't know how to share it.
So it should be in the top right.
Well, since it's already shared, you should just be able to go into your Google Docs or your Google Drive and open it, and all of Finau's changes will show up onto you.
Okay. Just a second.
We'll just try the data.
So we're just describing our experience of doing it, because I think I did that already.
Okay, where are you guys? Yikes. That is pretty sad.
Weren't we supposed to turn in to describe the data last week, or is that this week?
That was collected data. We got 100 on that one too.
Oh, perfect.
Share.
I don't know if, so do I just need to enter, like, just are describing our experience of doing it? Is that right?
Yeah.
It says, the direction just says, we write 1 to 3 paragraphs summarizing and describing our data. So
Okay, can I just, I'm sorry, go ahead, Raquel.
I'm thinking that's the results. Like, our final count was, we had 144 marshmallows out of 921 pieces in the first cup. And in the last cup, we had 123 pieces of marshmallows with 756 pieces total. So then, well, it's actually the next one where we reject the null and all that, but I figure he wants some of those numbers in there somehow. I could be wrong.
Okay, do you want me to read you what I wrote on this one? This is just mine. Okay.
About where we live in
Tell me,
40
Raquel, whether what I need to put in there. The purpose of the study was to determine is the proportion of marshmallow the same in the first and last cup of a Lucky Charm box. After measuring 16 cups out of the box of 16 ounces of Lucky Charms, it made sense that there was a cup of Lucky Charms for every ounce. There were 4 of us who measured our first and last cup. After I measured the first cup, I poured it into a bowl and then separate the marshmallow from the cereal bits by counting it to another bowl. Although our cups didn't exactly measure out the exact same amount, we found that the proportion of marshmallows in the first and last cup didn't have much difference. Raquel's first cup had a lot of marshmallows in it. Marissa was similar. Emily seemed to have a little bit more in her last cup of Lucky Charms. I found the same thing, although there was slight difference in the proportion of marshmallows in the first and last cup. When we put together our data and create a graph, we found there wasn't much difference between the first and last cup. We each live in 4 different states. When we consider the fact that these Lucky Charms had to be shipped by trucks from its destination, there were many factors that we needed to consider. Every time the box of Lucky Charms got moved, it got shaken by someone as they pick up the box, and perhaps when they are in cradle, which got moved around a lot. The forklift that moved it to the truck it is not exactly a smooth transition. The truck that moved it, which drove through distances, the turn and road conditions, that all contributed to the distribution of the marshmallow in the first and last cup. Hence the evenly distribution of the marshmallows. I also had to consider the fact that people who shop in the store, some of them have the tendency to shake boxes of cereal and then put it back. We just don't know, but these factors contributed to the distribution of marshmallows inside the box of Lucky Charms. And then looking at the data, I'm willing to conclude that 0 is contained within the mean of the sample. And then I had the graph.
Wow.
Was that way too much?
No.
Right, because I think that's what we're supposed to do this week, because last week we explained how we got it, and this week we're supposed to explain what we got.
And then we were also supposed to explain what things that we didn't anticipate while collecting the data.
Right, I think that's actually in the next one, though. Because the next one is make inference, where we have to, it actually asks for the p-value and all of that.
Okay. Which you had already done, Raquel, and thanks. Raquel did most of the work.
I know, seriously. She went above
Yeah.
We owe you, Raquel. We're gonna give you a medal.
Thanks. No, I had some extra time, and next week might be a different story, so.
Hey, but you know what? That's why we have a group. We're all here in it together, helping each other.
Mama.
Yep. Mama. So for now, if you want to, so then we can just turn this in right now, actually. If you wouldn't mind copy and pasting it into this document that Raquel has shared.
Okay. I'll just put it in Raquel's. Oh, I can't think. My brain just went stupid.
I added stuff to it too, so my part, but I don't know if that's what we need, so I don't know if we need to take it off or not.
So you want me to just put it in the one you had, Raquel?
Yeah, because we're all, it's all,
Sure.
we all have to do it together. It's, we just, one
Well,
person,
and you have
alternate.
It says in no more than 2 pages, so the whole thing
Yeah.
can't be more than 2
Mine is
pages.
exactly 2 pages. I shrunk the graphs. I shrunk it really small, so it'll
Oh,
both.
well, there's
fit
a
in-
graph already in there, so.
Yeah, I shrunk it and put it in 1 page.
Why is it?
I don't understand.
Okay, let me.
We're all looking at describe the data document on Google
Okay.
Docs, right?
Yeah.
Describe the data, yeah.
It's at 6 pages. Did she download it or something?
Is that? Am I in it? Oh,
Yeah, it says you're in it.
okay. I'm going to go and just basically copy and paste. First, I gotta download it as Word because it's on.
Oh.
So I inputted where I described the experience. Is that what we're supposed to do, or do we need to take it off?
So I don't think we need all of our different experiences. It's just like as a group together we.
Okay.
Should I take mine off then? Should I delete it?
Okay.
I don't think we need.
And I will go
I'll
to.
delete mine too. I think this is mine.
I'm gonna
And I'm gonna.
email
I'm
him
gonna attach mine at the bottom.
Oh.
Okay. Please. I think mine's gonna show up weird.
It's okay. I'll just go through and.
You know what's weird? Is that my other graph didn't show up.
It's
The
okay.
graph?
We have the graphs from Raquel, so.
Okay. Yeah, I got that from Raquel too, but my document, well, when I put it into this, it didn't show up.
Yeah.
Well, Raquel's got it, so she's just gonna submit it. Just shrink it, make it smaller.
So what we need to determine is, do we want do we want to just use what Fanal has written and we'll just change it so that it sounds more like all of us wrote it?
Yeah. So Raquel, you could just go through it and edit it.
We can go through it right now. We just need a...
And then up above, where the two samples you test for proportions, it's cutting off the text.
Yeah, I'm going to go through and... Because this right here just needs to be changed. You see what I'm highlighting?
I'm going to send him an email and ask him to explain it a little bit on tomorrow night.
Well, I think what we have is right.
Is it tomorrow night or tonight?
It's tonight.
It's tonight.
I'm pretty sure what we have is right. I just feel like we're overthinking it. So what I'll do, let's see. Hold on. Oh, that's not going to do anything. Okay, so do we want to use Fanal's, what she wrote, or do we want to combine what Raquel has too?
We can combine it. You know, she can kind of put it together. I just was giving her
How
some.
about we just all do it right now together, so then we can just turn it in, like have it all done? Because I think.
Well, I'm asking him for sure what he wants there, whether he wants numbers in the paragraph or just basic what we did.
What we could do is we can go over it together, and then and then once we do the group or the class meeting, we can ask him, and then if we need to add to it, we can before it's submitted. Who's gonna submit it?
I will submit. I think it's my week to submit it.
Okay.
Yes, kind of.
So are we taking?
Let's see. Okay, so sorry, I'm just trying to compare. Because that table in the middle is just messing everything up.
Is there a way to move it? Maybe drag it down to the bottom?
You know, I'll move it. It won't go down to the bottom.
Well, I had it in the order of the steps that it had at the top. Because I just copied and pasted the directions in there, and then it was in the section in that step. Does that make sense?
Uh-huh.
So this graph, all the graphs are supposed to be at the bottom.
You can you could probably cut and then paste it at the bottom.
Oh, there we go.
Just highlight it, and then I'm not very familiar with Google, so
It's okay.
did it work?
Hold on, I'm just moving everything up so I'm gonna put it behind everything. There we go. I'm just moving for now stuff because we have everything kind of just everywhere.
Right.
So.
And then you could just edit it.
Okay, there. So we have all of our graphs at the bottom.
Okay.
I'm gonna make them smaller because I don't think we need them that big.
Yeah, you can just shrink it. You can shrink it. It could be side by side.
Okay. We'll do that. I'll do that at the end. Let's just work out the wording right now, and then we can be done with the meeting.
Okay.
How does that sound to you guys?
I just asked him if we could email it before we turn it in for a look-see.
Yeah. Well, let's just like condense it right now, and then we can ask him just to make sure. So then I just don't want it to be where only one person is doing all of the editing.
All the work and stuff. Yeah.
Yeah. I feel like we can all do that a lot faster than just one person. And we don't have to worry about it, and we can just enjoy our week.
Sounds good.
Yeah.
I'm all about simplifying these days.
Well, I knew you were probably like slammed with 4 classes, and I was like, well, anything I can do helps.
No, I appreciate it. You know, it's okay. I wake up early and I stay up late to get it all done. Somehow it works out.
I don't know how you do it.
You know what? I haven't really been doing it. I'll just say that. Okay. So Raquel says, and I'm just going to read Raquel's because Fanaz already read hers, and then we can kind of.
Yeah, you can basically take out after I measure the first cup. You can edit that out. You know.
Yeah.
So trying to look like it's, it's all of us.
Yeah. So in a box of 16-ounce Lucky, I'm going to start with Raquel's paragraph. In a box of 16-ounce Lucky Charms, we found that there was 1 cup for every ounce that was in the box. There was 4 of us who measured out the first and last cup of Lucky Charms, and we counted how many marshmallows and cereal bits that were in the first and last cup. We live in 4 different states, which means that we got our box of Lucky Charms from 4 different states.
Did you guys all got yours from Walmart?
Yeah.
Mine was.
Yeah. No, I didn't.
Mine was from the grocery store.
Our Walmart here, remember, they didn't have they had every size box except 16.
Okay, that's good. That makes it fair. Go ahead.
Yeah. So then after measuring out the cups of Lucky Charms and creating a graph, we found that there was a slight difference in the proportion of marshmallows in the first and last cup. After creating a graph to determine the proportion of marshmallows in each cup, we found that there seems to not be much of a difference between the first and last cup. The graph tells us that there wasn't much difference. Okay, that's just repeating it.
That's just too much, yeah.
So I think we should say like what our graph says, so he knows that we understand. We know how to read the graph, but I don't know how to put that in words.
Well, let's just do this, and then you can ask him. We can go back. Right now we're just trying to combine all of it, and then we can go back through and add stuff if we need to.
Okay.
So perhaps when we measure out these marshmallows from our box of Lucky Charms, judging from the graph that there was not a lot of difference between the first and last cups, there is a chance that when these boxes got shipped during transit, the boxes got to be.
Yeah, we can take that out.
The boxes were shaken up.
Yeah.
To be shaken up quite a bit.
So yeah, take out to be I think it's simplified what Raquel said, the boxes were shaken out.
Well, it was like in the middle of the night when I did this.
I know, it sounds great. Which may have contributed to the fact that the marshmallows were evenly distributed between the first and last cup. We took care to make sure that we did not shake the box as not to be biased in our measuring of the data. However, when we finished measuring out the first and last cups, I think this is repetitive.
Yeah, it's repetitive.
Right.
I am too repetitive.
Difference between the first and last cups. We attributed the fact that these boxes had been shipped by truck and handled by people who packed them and moved them. Perhaps people, when they went shopping, might have picked up a box and shut them. There were a lot of factors in the distribution of the marshmallows.
But we can take out some of the sentences to make it make sense.
So wait, I'm confused. So this one in red, who wrote this one? Was that Raquel?
I wrote it because I thought, I'll just contribute a little bit, to the.
Well, it's perfect.
To the summary, and that's why it's a lot similar from what I wrote And then I went and wrote again. I thought I had to submit my own, and she had to submit.
Oh, okay. So this second one is what you wrote.
Yes,
Okay.
that was at 4 in the morning, so you can't blame all the.
No. No, guys, this is beautiful. I was just confused. I was thinking, wait, did Raquel write? Is this one in red, Raquel, or is it for now? Okay.
I think it's for now.
I got up and I go, oh, Raquel needs help. I better type something in there.
You guys, this is perfect. You okay, Baba? Sorry, he's choking.
And then I went and read what he wanted us to do. He wanted 2 pages, of 3 paragraphs of,
Okay.
describe the data and make inferences, and the other paragraph.
Yeah, this is just describing the data, though. The next assignment is where we put the make inferences. So it's, I don't know, they split it up into little bitty steps.
Yep. No, you guys were good. Okay.
Well, maybe he'll show us an example tonight.
Yeah.
Okay, so this last paragraph, okay, so perhaps when we measure out, I'm starting from right here, perhaps when we measure out these marshmallows from our boxes, cups there.
From the boxes, not our boxes, from the boxes of Lucky Charms.
So perhaps when we measure, sorry, I'm like, not like an English person, but I don't know.
Perhaps when we measure out marshmallows from Lucky Charms.
Yeah, we could take out a lot.
This is why group work is just wonderful.
This is more of my expertise is right here. I can do English. Okay, so I'm just going to put space between right here so we know. Okay, I just don't like this sentence right here. Like, just to reword it, I mean, not that I don't like it. So perhaps when the marshmallows were measured out from the boxes of Lucky Charms, what are we trying to get at? Does it make sense when we say, judging from the graph, there was not a lot of difference between the first and last cups?
Yeah.
Okay.
Maybe
So I think you just take this out.
Take it out.
Say the graph shows, or the data shows, that there was not a lot of difference.
Glass dead. Hey, Cole. Okay. So you're okay, don't worry about it. Don't apologize. Sorry. I just need to get my son entertained for a second. Yeah, Mom. Bless you.
Okay.
Okay. Okay, guys. So perhaps when the marshmallows were measured out from the boxes of Lucky Charms, it just doesn't make sense to say then the data shows that there is no.
Yeah.
Right. No, it just doesn't make sense.
There's a lot of repetitive and
Well,
yeah.
It's because I deleted out the other sentence, and so that's why. I'm just trying to figure out what we're trying to say. The data shows. Okay. The data shows that there is a chance. Okay, we're gonna probably put this and take out that.
Yeah.
And we're gonna do this.
Oh, what is the word they use? The data shows. They don't use the word chance. They use.
Sufficient.
We are confident or sufficient that there's not much different.
Oh, we could say we determine,
Right. Yeah, but
We're trying to just go in to say that what we read from the data So the data shows that there's not much of a difference, that when these boxes got shipped during transit, the boxes happened to be shaken up. Still not liking this sentence.
I still not like that sentence either.
I'm just trying to figure out. So what are we trying to say? I guess that's, maybe we can just rewrite it.
We could start by saying there are many factors that contribute to the distribution of the marshmallows. I don't know. Somebody put in something there. I don't know.
I think if you think in terms of our hypothesis,
Okay, rather than concluded, we say contributed.
And what happened? It was in bold. I had the answers all bolded.
That when it was shipped. Okay, I see why you didn't have contributed at the beginning. Marshmallow being distributed.
Who's blue? Marissa.
Marissa.
And Finale is red. Okay.
I'll tell you up at the top. Okay.
Well, she.
So this is what I just rewrote it. In collecting of the data, there are many factors that contributed to the distribution of marshmallows in each box. Some of these factors being, when the boxes were shipped, they were shaken up, which may have contributed to the marshmallows being evenly distributed in the first and last cup. Perhaps when the marshmallows were measured out from the boxes of Lucky Charms, we need to talk about how each of us have had different measuring cups.
Yeah, we could take that paragraph and stick it next to the top one, and then take that paragraph and stick it closer to the bottom.
Yeah, hold on. I'm gonna. Well, hold on.
I did marshmallows and she did marshmallows.
What do you think about that? See, that's something. This is something like we didn't anticipate happening. So another factor is that when the marshmallows were measured out from the boxes of Lucky Charms, we each had different one-cup measuring cups that might have skewed our results.
I don't know though, because I mean, a cup is a cup.
Yeah.
There's all kinds of different
But it
ones.
depends if like we each put it to the line, to the right line.
Yeah.
Well, mine was just a 1 cup. You fill it to the top and level it off.
Yeah, that's mine. Well, we don't have to. I just didn't know. That was something like we didn't
I don't know.
anticipate happening.
That it's supposed to be a universal measurement.
That's okay. We can just put it down here. We don't have to have it. I'm just. So another. So, however, okay, another factor is that each member did not shake the box as to not be biased in measuring the data. Shake the box of cereal in order to reduce biased data. Does that make sense? What do you guys think that sentence right here that I'm highlighting?
It's fine.
So then, however, when we finished measuring out the first and last cups, we didn't find a difference between the first and last cup. Did we already state this in this first part? So
It looks like we're already drawing a conclusion already by looking at the graph.
or we're just supposed to describe it, not.
Yeah, we're supposed to describe it and not. We can allude to what the data looks like, but we can't already draw a conclusion because we haven't run the test.
No, that's fine.
We can say that it looks like they're the same, but we're going to run the test.
Yeah. So we can also attribute to the fact that these boxes have been shipped by truck and handled by people.
Yeah.
We've already talked about shipped by truck.
Well, plus when you take it to the store, they have to unload it and then stock the shelves. That's a lot of movement.
Yeah, I'm just saying, we've already stated the truck, the shipping.
Every bump in the road.
But we can also attribute to the fact that these boxes
Yeah.
were handled by different people who packed them and moved them, packed them and moved them. Perhaps people. Okay, so we can also attribute to the fact that each box of cereal was handled by different people who packed them and moved them, as well as the people in the store who might have picked them up, who might have picked up a box and shook them. There are a lot of factors to consider in the distribution of the marshmallows.
Okay, could you, Marissa, since you're the English person, could you condense that sentence, into a more, so there's not repetitive of, pack the box,
Yeah, I know that's what I'm doing right now. I just was trying to get it all into one idea, and now I'm going to. Okay, I'm just sorry. How I work is I have to read it out loud.
Yeah.
I am just. Okay, so we can also attribute to the fact that each box of cereal was handled by different people. We can say those who shipped the cereal,
and those who received it.
those who stocked it,
Yeah.
and those who might have, and sorry, I write things out and then I'll redo it.
That makes sense. Yeah.
So we can also attribute to the fact that each box of cereal was handled by different people. Those who shipped the cereal, those who stocked it, and shoppers who might have picked it up.
Awesome.
Picked it up to view it.
Yeah.
There were a lot of factors to consider in the distribution of the marshmallows. Okay, so that's what we have. What, gents? Okay. What do you guys think? because what in our instructions it says we need to have 1 to 3 paragraphs summarizing and describing your data.
Yeah, we got that's plenty good.
I think. Okay, so I'm just trying to make it pretty. Okay, so we have 2 pages and our graphs are on.
Yeah.
Except we need to get this one. Oh, there we go. Thank you. Okay, guys, I think that's it.
Thanks, Marisa.
Oh, thank you guys. You guys are awesome. It's so bad. I feel like I haven't done anything.
Well, you guys are a great group because I remember there was this huge project we did in my Math 108 class. I literally almost did the whole thing because there hardly anybody contributed.
Yeah,
And so, yeah.
Projects like that.
And in fact, one guy didn't do any. And after I submitted it, he called me. I literally sat down and did his whole project right there. I did the research. I did everything. The calculations. It was pretty sad. My husband said, it might as well just be a work submit twice.
I know, right? I've had so many projects like that, so I really appreciate you guys. Okay, so I'm going to stop the broadcast.